This presentation will present ProgSnap2, a flexible format for programming process data. The work was done by the SPLICE working group on small code snapshots, and it will be presented by several members of the team. My name is Kelly Rivers, and I'm an assistant teaching professor from Carnegie Mellon University. I'll present the introduction. Data collected from student work has historically led to insights and tools that can improve student outcomes. Our goal is to make it easier for researchers to share data, analyses, and tools that are related to programming snapshots. A snapshot is a code artifact created by a student at a specific point in time. This can range from a one-line program to a multi-file program to a block-based program. Our work is motivated by the findings of the DataStand project, which ideated on how programming data formats can be standardized. It is also an extension of the original ProgSnap data format. ProgSnap2 greatly extends the types of data that can be represented and makes the format easier to analyze. Snapshots do not fit well into a traditional educational data format, as they contain much domain-specific information that is not captured by a plain text entry. Additionally, different datasets collected by researchers may vary greatly in programming language, program size, and which metadata was collected. We have built a data format that prioritizes both the data producer, with a range of options for representing different snapshot types, and the data consumer, with a minimized number of specialized features. This makes it possible for researchers to gather several datasets from different contexts and run a single analysis method on them. First, we'll tell you a little bit about the ProgSnap2 format and how it works. Then we'll describe a case study we ran on multiple independent datasets that had all been aligned to the ProgSnap2 format. This demonstrates how a common format makes collaborative analysis easier.
Next, we will discuss the ProgSnap2 format. My name is David Hovemeyer, and I am an associate teaching professor at Johns Hopkins University. We will look at three specific aspects of ProgSnap2: its design goals, its concrete data representation, and the structure and semantics of a dataset. We had three main design goals for ProgSnap2. First, we wanted ProgSnap2 to be capable of modeling data from diverse sources. Second, we wanted ProgSnap2 datasets to be faithful to the semantics of the data as represented in their native format. Third, we wanted ProgSnap2 datasets to be easily consumed by standard tools and libraries. A ProgSnap2 dataset includes three types of files. CSV files are used to store all of the structured data in a ProgSnap2 dataset. We chose to use CSV because it can be loaded and analyzed by a wide variety of software tools. A code state represents student programming artifacts such as source files that are associated with a programming activity event. ProgSnap2 supports several ways of representing code states. A ProgSnap2 dataset may include or link to arbitrary resources. This is useful for including additional information such as an assignment description with a ProgSnap2 dataset.
My name is Corey Bart, and I'm an assistant professor at the University of Delaware. I will now give you a quick overview of a ProgSnap2 dataset, starting with the file system layout. From the file system perspective, there are two top-level files, maintable.csv and dataset-metadata.csv. The dataset metadata file is currently quite simple, holding fields like the current ProgSnap format version used by this dataset. It also includes information about the dataset, such as how code states are stored and how the events in the main table are ordered. The main event table is a central feature of a ProgSnap2 dataset. It consists of a collection of records. Each record is a tuple of values corresponding to the main event table columns. The main event table has a huge number of optional columns, but only a small set of required columns, shown in bold here. Each row gets a unique event ID and should be classified via an event type. The format specifies over a dozen common event types corresponding to important types of student programming activity, such as compile, submit, file edit, and intervention. Link tables provide a way of associating IDs or combinations of IDs with a resource. For example, for a dataset containing events from several courses in several academic terms, the dataset could contain a link table mapping a combination of course and term with a course website for that specific instance of the course.
My name is Thomas Price. I'm an assistant professor at NC State University, and I'm going to be talking about the case study that we performed to evaluate how well ProgSnap2 facilitated our ability to carry out authentic research. That research concerned compiler error metrics. These are intended to quantify the extent to which a student struggles with compiler errors while programming. They're traditionally calculated automatically from students' log data, and they've been correlated with students' final grades. In particular, we looked at the error quotient, the Watwin score, and the repeated error density metric. We set out to answer two research questions. First, how effective are these error metrics at predicting final student grades, and how consistent is this across data sets? And second, are there meaningful differences between these three error metrics? ProgSnap2 gave us the ability to address our research question using 5 distinct data sets. These were collected at different universities, under different programming contexts, and they featured different numbers of students, numbers of tasks, and different sizes of data. Now, importantly, 3 of these data sets could not be shared among the research team due to privacy reasons, so instead of sharing the data, we shared the analysis scripts, and then returned the results to share amongst the team. This reflects an important challenge for a lot of collaborative research, and we wanted to see how well ProgSnap2 facilitated our ability to overcome that challenge. This table presents a number of correlations for each metric across data sets. First, let's look at the correlations between each error metric and a student's grade. What we see is that each error metric is weakly correlated with a student's grade, and that this is fairly consistent across metrics, but varies across data sets. This suggests that all the metrics are somewhat, but not very, predictive of a student's final grade. Next, let's look at the correlation among the error metrics. What we see is that each error metric is highly correlated with each other error metric, which suggests that there are not strong or meaningful differences between these error metrics. This suggests that despite 10 years of research on the topic, error metrics have not changed much since their original conception. Reflecting on our experience with ProgSnap2, we find that it did greatly simplify some aspects of the data analysis process. In particular, it allowed us to write a single analysis script, which we could then apply to 5 different data sets. And we were surprised to find that the analysis script was able to run somewhat smoothly, even on data that that the designers had not seen previously. We also found that converting an existing dataset to the ProgSnap2 format was relatively low effort and only took a couple of days. However, we also note that ProgSnap2 did not solve all of the problems that are inherent to research. And in particular, we still had to clean the datasets, we still had to verify our results, and fix a number of bugs, which did require us to redistribute the analysis script, run it again, and then share the results.
Hi, I'm Brett Becker from University College Dublin. In terms of future work, ProgSnap2 has the potential to greatly facilitate collaboration, data sharing, and the gaining of insight across the community. The next step is wider adoption. We're looking for collaborators to produce or convert datasets to our format, to develop new logging systems guided by ProgSnap2, and to use and contribute to cross-dataset analysis code. ProgSnap2 was developed by a working group from CS Splice. You can join the discussion by emailing David. You can also check out the specification at the following URL. And we also have our code and public datasets from this study on GitHub. Thank you for watching, and we look forward to collaborating with some of you in the near future.